Welcome to today's webinar, Deep Dive on Amazon EC2 Instances, featuring new instances. Our presenter today is Adam Beglin. Adam is an HPC solutions architect with over 15 years of IT experience in various roles. Today with us, we also have Michael, Jack, and Leah. They are our webinar moderators who will be engaging with you and answering your questions throughout the presentation. Adam, welcome. The floor is now yours.
Hi, thank you all for coming. My name is Adam Beglin, and I'm a solutions architect on the high-performance computing team here at AWS. My customers are doing things like gene sequencing, computational fluid dynamics, and semiconductor design on AWS today. Because of this, I spend a lot of time diving into the features and capabilities of each EC2 instance in order to help my customers get the most out of them. So what I want to do today is talk to you guys about all of our instances and what they're best suited for in order to help you choose the right instance for your workload. So in this session, we're going to dive deep into all the instances that we have available on AWS, and even some of the newer ones that we just announced recently at reInvent. We're also going to talk about how the instances are different from one another and what you'll need to look at in order to find the right one for what you're doing on AWS. My goal is that by the end of this presentation, you'll be able to quickly glance at that list of instances and sizes that you see in the console when you go to launch, and be confident that you're picking the right instance to fit your needs. So let's dive in. First, let's start with a quick refresher of what EC2 instances are. So EC2 instances, they are virtual machines. So that means that they're guests that are running on top of a hypervisor that's running on top of a piece of physical hardware. And we launched our first EC2 instance back in 2006. Back then, it was actually really easy to decide which instance you're going to launch because you didn't really have a choice. We just had one instance, and because of that, we didn't even really have a name for it at the time. We just called it the EC2 instance. You didn't get to choose how many virtual CPUs you wanted or how much RAM you got. You went to launch an instance, and this is what we had. And it was pretty nice. We eventually gave it a name and started calling it the M1 instance. But customers, they wanted more flexibility and they wanted more choice. So we started to iterate on the platform and release a few more options. And as you can see, we've been quickly adding new instances ever since. But not only have we been adding more instances to the platform, we've also been making some changes underneath the hood of EC2 in order to give you the best possible performance out of it. So when I talk about instances, I'm going to spend my time talking about what we call our current generation instances. And these are the ones that have been released just in the past few years. And the reason I'm going to focus on those is that while you can still launch the early instances that you see on the left-hand side of this timeline, they're typically slower and more expensive to operate than the newer instances that you see on the right. So before we start diving into the instances themselves, I want to quickly go over how we name them so to make sure that we're all speaking the same language. The instance that you see here is what we call a C4 large instance, or a C4.large. And the first letter you see is what's called the instance family. Now the letter in the family stands for what the instance is best suited for or what sort of resources it has. So you have C that stands for compute, R for RAM, I for IOPS, so on and so forth. The next number you see is the instance generation. And you can kind of think of this like a version number within that family. So you have a C4 instance would be newer than a C3 instance. And lastly, you have the different sizes of instances. And I've heard these called t-shirt sizes, which is a pretty good way of thinking about them. So you've got small, medium, large, extra large, so on and so forth. And what this means for you is that today you have a lot of choice and you have a lot of flexibility when you go to launch your instances. You have the ability to pick what type of processor you want, whether it's Sandy Bridge or Haswell or Broadwell. You get to choose how many cores it has, how much RAM you need, whether you need accelerated graphics or not. you get to choose all of the things that go into picking the right instance for the right job. Because really, that's what you're doing. You're hiring a server for a job. Now, some jobs are easier than others. If you have one server that's displaying cat pictures on the internet and another server that's trying to come up with a cure for cancer, they're probably going to have different resource requirements from one another. So the first step to figuring out which server you'll need is to actually understand what your application requirements are. Now, it sounds simple, but you'd be surprised on how many people skip this step. I see most people just guess as to what their needs are. And when you do that, you usually end up over-provisioning or under-provisioning. So this means you're either wasting money on hardware that's just sitting there idle, or you end up giving a bad experience to your end users. One of the most powerful things that I think AWS gives you is the ability to quickly change from one instance size or one instance family to another. And because you're only paying by the hour, it's really easy to actually do the testing to make sure that you're hiring the right server for that job. And there are a lot of factors that go into making sure that you're choosing the right EC2 instance. And you can see a couple of them on the screen here. There's some applications that are bound strictly by CPU performance. Others are limited to the amount of memory available on the system. Most applications will use a combination of disk, memory, network, and CPU, but almost all of them are constrained by just one of those as you try to scale up. So when it comes to understanding your application, you'll want to look at all of these factors and do some testing in order to determine which one most affects the overall performance of your application. And once you've done a little bit of that testing, you're generally going to know what you're constrained by. And from there, it's pretty easy to start picking the right instance family. If you know you'll need a lot of memory, you should probably start with an R4 instance. If you need raw CPU performance, you should go with the C4. If your application's actually pretty well-rounded, start with one of the general purpose instances, either the T2 or the M4. By approaching EC2 from the perspective of your constraint, you can quickly narrow down to the right instance family, and from there, it's just a little bit of work and a little bit of testing to find the right size within that family. At AWS, we want you to be as highly utilized as possible. It's really important for us that you're getting your money's worth out of that instance that you're paying for. Now, what high utilization means actually depends a lot on your application and how it's using the system. You know, obviously something that's at 100% utilization can't handle any more work. But even something that's 70% utilized may be doing all it can. Most metrics are aggregated over a few seconds or a few minutes. So if you regularly see something at 70% utilization, it may actually be hiding short periods of 100%. Or then there are things like hard drives with spinning platters that actually can't be interrupted even if a high priority task comes in. So something like a hard disk, when it's heavily utilized, even high priority tasks are going to start to queue and slow down the overall performance of your application. So to demonstrate this, we set up a very simple example. We installed the open source MediaWiki application, and we started to throw some load at it with a tool called Siege. And we ramped up the amount of requests that were going to it, and we stopped and we measured along the way. Here you can see that at our peak, we're about 22 requests per second. So let's look at what's happening under the hood and try to figure out what we're constrained by. Here you can see the memory usage of the machine. It's really flat over the course of the entire test, and there's a lot of free RAM and there's no swapping going on. So obviously memory isn't going to be a factor for our instances. Next, let's look at disk utilization. Here you can see two graphs. There's the one on the left that has the number of read and write operations per second. It's at about 20, and that's easily handled by any EBS volume. And on the right, you have the throughput to EBS. And this is in the hundreds of kilobyte range, which is, again, no big deal for EBS. So how about network traffic? Well, this is at least a more interesting graph because it goes up with the load. But on the left, you can see that it's only about 200 packets per second, which is really, really small. With enhanced networking and our largest instance types, you can get up to 1 million packets per second on a single instance. And bandwidth-wise on the right, the network traffic is in the hundreds of kilobyte range, which again is no big deal for even the smallest EC2 instance. So finally, let's look at the CPU, and here you can obviously see what the problem is. This system has 2 virtual CPUs, and they're both around 100% utilization. Now, if we wanted to, we could do a lot of application tuning, maybe some caching, and see if we can decrease this CPU load. But from an instance size perspective, we're really at the maximum load that this instance size can sustain, and we'll need to move to a larger instance if we don't make any more changes but want to support more users. Instance selection and application tuning, they really go hand in hand, and it's a great way to understand the scaling characteristics of your application. Now, if you don't know where to start, the EC2 documentation actually provides a list of workloads that are really well suited for each family. Once you've narrowed that down to that specific family, you'll need to start to consider the size of the instance that you need. I suggest that you start testing with a smaller size instance and see what kind of work it can support. So maybe you're looking for the number of concurrent users on your website. Start small, see how many users you can get, and then go to the next size up. If the number of concurrent users that you could handle didn't double, you might actually be constrained by something else, and you'll need to go to back to your metrics to find what that is. Now, it might be a little bit cheesy to quote your own documentation, but I really like the sentiment behind this. On AWS, it's pretty easy to quickly get your application up and running on an instance. So instead of doing what I see some customers do, which is install a synthetic benchmarking tool and try to count the number of flops or whatever you can get out of that instance, I suggest that they just install their application and start sending some realistic load to it. So if you have a mobile application, simulate a real user navigating around in it. If you have an HPC application, run some of your common models. If it's a data warehouse, run your typical business intelligence queries. You can even do things like use the spot market during your testing. So you can run your tests on larger and realistically sized instances, and the testing is still going to only cost you a few pennies an hour. By running your tests with a real application, not only will you know how it's going to perform as you go to production, but you'll also be able to understand how it scales as your load starts to ramp up on your instances. Now, I work with a lot of customers, and I see a fair number of bad practices when it comes to trying to choose an EC2 instance. I've seen customers test every one of our instances and every one of our sizes of those instances, trying to find just the right one, when they could have just looked at their application, seen how it interacts with the system, and used that information to narrow it down to just a handful. I've also seen customers favor our old generation instances, and they do this because they think it'll be cheaper because they're running on an older instance. But in reality, this usually isn't the case. And that's because newer systems with newer processors usually require less power and less cooling. This means it's cheaper for us to operate them so that we can pass the savings back to you as the customer, and you'll see that in the instance price. So now let's dive into instance sizing. We build our instances in such a way that allow you to scale both vertically and horizontally. So let's take a look at the C4 family on the screen as an example. A C4 8x large instance is the largest C4 instance that's available on AWS, and it's generally suited for instances that require a large amount of compute resources all on a single machine. Now, that C4 8x large instance has roughly the same amount of resources as 2 of the C4 4x larges. So that means that those two C4 4x larges will be roughly equal to that one C4 8x large in things like the amount of virtual CPUs it has, the amount of memory that's available to it, and the amount of network capabilities that it has. And then those C4 4x larges are going to be roughly equal to 4 of the C4 2x larges, and so on and so forth. Now, what this means for you and for your application is that you get to decide how you're able to chunk up your work in order to best utilize those resources. So let's take a web server, for example, where a smaller instance can just as effectively handle a request as a larger one. More of the smaller instances may actually be a better choice because with small instances, you're not only able to spread your footprint over more availability zones and get higher availability, but you also have more granular control when it comes to things like scaling. If you're adding an 8x large instance, when the load coming in only requires a 1x large, then you've got a lot of extra compute sitting around, sitting idle, that you shouldn't be paying for. So the goal, when it comes to instance sizing, is to find the right instance size for the unit of work that you're trying to match it up to. So let's look at a quick example to demonstrate how smaller instances can actually save you money. Imagine this is the load coming into a website that you're running, and you have your instances set up with auto-scaling. At some points in the day, you're going to have very little utilization. This is probably when most of your customers are asleep. And then you have peaks at a few different points in the day whenever your peak demand comes in. Now, let's say you were using M4.large instances to meet this demand. During most of the day, you're probably only going to have 1 or 2 of those servers operating. And at the very highest peaks, you'll spike up to 3. Now, there's a lot of gap between the load coming in and what the servers can fulfill. But with a setup like this, it would cost you about $5 a day, which isn't too bad. But what if you were then to switch from that M4 instance to a T2 small instance? And that T2 small is going to give you far more granular control. Here you can see that the gaps between the demand and what the server is able to fulfill are far, far narrower. And that means that you're more closely right-sizing your server capacity to the demands of your customers coming in. Now, during those peaks, you'll be adding a lot more servers. But because they're smaller and better match to the work, you'll be paying a lot less. In this case, you'd only be paying about $1.80 per day, which is a 60% savings just by switching to a different instance type from the M4 to the T2. All right, so let's start diving into the instances themselves, and we'll start with the general purpose category. These are instances that are balanced in terms of resources that are available to them and are pretty well suited for most workloads. The first one we'll talk about is the M4 family. The M4 instances launch with either Haswell or Broadwell processors and have a good mix of resources like compute, memory, and network performance. They come in a lot of different sizes, which can support many workloads, big and small. So if you're unsure of which instance that you'll need, the M4 is probably a good one to start with. Now, once you start getting a better understanding of your application and the requirements, you may move to other instance types, but the M4 being balanced would be a good starting point. We see all sorts of applications running on M4 instances. These are things like websites, databases, caching servers, SharePoint, and many other enterprise applications are a good fit for the M4. The other type of general purpose instance is the T2 family of instances. Now, the T2s are the lowest cost instance available on AWS, with the T2 Nano being about half a penny per hour. They're really great for workloads where CPU demand varies over the time because of its burst credits, which we'll talk about a little bit later. Things like websites, development environments, or even small databases are a really good fit for T2 instances. With T2s, you get a baseline of CPU performance all the time And that baseline is set based off the size of the instance. So the larger instance you have, the more baseline performance that you're going to get out of it. From there, you're going to earn CPU credits to burst above that baseline for all the time your CPU is spent idle. Because there are a lot of workloads that don't need to use all of the CPU all of the time, the T2 family is a great way to pay less and still get the performance that you need when you actually need it. So let's go a little bit deeper onto those credits. So you can think of CPU credits in a T2 instance kind of like a bucket. When you first boot an instance, you'll get a fair number of credits that are already sitting in that bucket. These credits are going to handle things like booting your operating system, starting your application, and handling that initial load that you started that instance for. Now, once the load starts to go down and that instance becomes idle, you're going to start to see a steady stream of credits flowing into that bucket. Now, once the usage goes back up, you'll notice that a single burst credit will allow you to use 100% of one CPU core for 1 minute. Credits are also going to expire out of that bucket after 24 hours if they're not used. And in order to make sure that you're getting the best possible performance and that you're right-sizing your EC2 instance, you'll want to monitor that credit balance and that credit usage. And as you can see, we offer a few CloudWatch metrics to help you do so. The line you see in blue is your CPU credit balance. So this is going to tell you how many of those credits you have left in that bucket. So as your usage goes up, as you start to use credits, that balance is going to go down. The line that you see in orange is the CPU credit usage. This is going to tell you how many credits you're using on a per minute or per 5-minute basis as you're using CPUs. So by using these credits, you can get a good idea of both how fast you're earning them and how fast you're using them over the lifetime of your instance. And you'll want to use those to ensure that you're right-sizing your instance to make sure that you're bursting when you need it. Next, let's talk about our compute-optimized instances. For compute-optimized workloads, there's really only one family, and it's the C family. But we have a few generations within that family that customers use. The most recently available compute-optimized instance is our C4 instance. C4 is our newest generation of compute instance, and it provides a Haswell-based Intel processor running at one of the highest clock speeds available on AWS. So the base clock rate is 2.9 gigahertz. However, by utilizing Intel Turbo Boost, you can turbo up to 3.5 gigahertz when you're running on 1 or 2 cores. The C4 is a great instance if you have CPU-bound applications like HPC workloads, game servers, and high-traffic websites that don't require much RAM. But an instance that I'm really excited about that we just announced at reInvent is the C5 instance. And this should be coming out early this year. The C5 is going to be our next generation of compute family instance. And the C5 is exciting for a few reasons. The first reason that I'm excited about it is that it's far more dense than any of our current compute-optimized instances. So the C5 instance will have 72 virtual CPUs all on a single machine. Compare that to the 36 virtual CPUs that the C4 8X Large has. This means that you can have even more compute power all in a single box and not need to cross the network as often, which can be a pretty big boost for a lot of applications. It'll also have the latest generation of Intel Skylake processors, which feature an AVX 512 instruction set. Now, AVX and AVX2 were available on the Haswell processors, but AVX 512, if you're running a floating point intensive application that's very compute heavy, it can provide a big boost to your performance. And the last really cool feature of the C5 instance is that it's going to contain our latest generation elastic network adapter. And that's going to provide even better network performance from one EC2 instance to another that's available than what's available on our C3 or our C4. Next, let's talk about memory optimized instances, which we have a few today. The R4 instance is our newest memory optimized family, and it's available for you to launch right now. The R in R4 stands for RAM, which is a good way to remember it. Now, the R4 family of instances feature DDR4 memory and a moderately clocked Broadwell-based processor at 2.3 gigahertz. The entire R family of instances have higher memory to CPU ratios than you'll see in the compute or general purpose instances. So with the R family, you'll get about 8 gigabytes per virtual CPU. Now, what's really interesting about the R4 instances is that even the smaller instance sizes offer peak network throughput of up to 10 gigabits per second. This is significantly more than the previous generation instances had available to them. And they do this by using an I/O credit mechanism to allocate network bandwidth based on the average bandwidth utilization of the instance. So what this means for you is that for most workloads, you should be able to expect to get that 10 gigabits of network traffic when your applications are using it to transfer data from one instance to another. So you can choose your instance for its memory requirements and not worry about its network throughput. Another instance that we recently launched is the X1 instance. And the X1 is really cool because it's the largest instance that we have on AWS today. With the X1 family of instance, you can get up to 2 terabytes of RAM and 128 virtual CPUs all on the same machine. It's a great fit for apps that have a huge memory footprint and require that all to be located on a single instance. We built this because customers were looking for an instance for large SAP HANA workloads, but it's really useful for any big in-memory database. We've also seen customers using it for big data processing systems and even some HPC workloads. The X1 also features our elastic network adapter and provides network speeds up to 20 gigabits per second. The next set of instances that we're going to cover are our storage optimized instances. The first storage optimized instance is the D2, and the D in D2 stands for dense storage. These D2 instances are filled with high capacity magnetic disks, and they're an excellent choice if you're building a distributed storage system that needs a large amount of local storage or streaming throughput. Now, keep in mind that because these instances are using disks that are physically attached to the instance, you'll need to ensure that your data is replicated so that you won't lose any data in the event of a hardware problem on that instance. Because of that, we see these instances used for things like Hadoop, MapReduce, distributed file systems, and log and big data processing systems. Now, if you're looking for a high number of IOPS for random reads and writes, you'll probably want to start looking at the I2 instances. The I2 instances have very fast SSDs, and along with them, 32 virtual CPUs and 244 gigabytes of RAM. They're really great for transactional workloads like databases that require a significant amount of random I/O, and online transaction processing systems. The I2 8x large instance can achieve 365,000 IOPS, which is about 10 times more than you'd be able to get from EBS all on a single machine. Again, these are disks that are physically attached to the instance, so you'll need to make sure that you have data backups and replication. But hard drive technology keeps evolving and keeps getting faster. So we developed our next generation of I/O optimized instances that are going to be coming out very soon. We're calling these the i3 instance. Now, in addition to featuring more RAM and a newer processor, these instances are also going to have more than 15 terabytes of NVMe-based SSDs. Now, NVMe is a relatively new storage technology, and it uses the PCI bus to allow you to get on these instances up to 3.3 million random IOPS, and up to 16 gigabytes per second of sequential throughput. So these are going to be screaming fast machines, and they're going to be really useful for all of your super heavy I/O workloads. But if you don't need that much disk performance, or you're looking for a more durable storage solution, you can attach EBS volumes to any instance. Now, EBS is another big subject, and we have deep dives into EBS all on its own. But what EBS allows you to do is decouple your storage requirements and choose them independently of the other factors that go into picking your instance. So just like network throughput, throughput to EBS is a function of the size of the instance. So the larger the instance, the more EBS throughput that you're going to have available to you. But because of the versatility of EBS and how you can exactly right size it to fit your needs, I highly recommend using EBS for workloads that don't need the performance of the I or the D families of instances. And lastly, I want to talk about accelerated instances. These are instances that have additional hardware that can perform processing functions in addition to the onboard CPU. The first one of these instances is our G2 family of instances. Now, the G in G2 stands for graphics, or GPU. And the GPU that's available in the G2 instance is the NVIDIA Grid K520. These GPUs, they're best suited for workloads like media rendering, and they're capable of encoding up to 8 real-time high-definition streams at 720p, or 4 of them at 1080p. They're also really useful for engineering or graphics-intensive 3D applications that are using DirectX or OpenGL. But the G2 instances shouldn't be confused with our latest generation of GPU instances, which we launched just a few months ago, called the P2. Now, the P in P2 stands for processing or parallel, and that's really what these instances excel at. The P family of instances are outfitted with NVIDIA K80 GPUs. These K80s have about 2,500 cores and 12 gigabytes of onboard GPU memory. They're really good cards for things like deep learning workloads, HPC simulations, and batch rendering. Any workload that can take advantage of GPUs for computational capabilities are a really great fit for P2 instances. Our largest P2 instance has 16 different GPUs all on a single machine. And it can use things like GPU peer-to-peer to communicate with each other across that PCI switch. This is especially important for applications that require a lot of GPU to GPU communication. They also feature the 20 gigabits network bandwidth available on our ENA network. And lastly, our most recent optimized instance, which is currently in preview, is the F1 instance. So the F in F1 stands for FPGA. FPGAs are useful for all sorts of workloads that can benefit from hardware acceleration or specialized hardware to meet the demands of a compute pipeline. These are workloads like financial computing, genomics, accelerated search, and even image processing. We offer 8 of the Xilinx UltraScale Plus VU9P FPGAs in the F1 instance, and we allow them to communicate to each other just like GPUs over a PCI fabric. Now, FPGAs have been around in computing for a very long time, but they're relatively new to the cloud. Because of this, we're really excited to see how customers are going to use these instances to accelerate their compute-intensive applications. So when it comes to picking the right instance, start small with an instance family that looks like it would be the best fit. From there, you can do some testing, change the size, and then test again to validate that you're picking the right one. Here you can see a flow chart that I've built, which goes over all of the things that we talked about today. and it walks you through the decisions that go into choosing the right instance family. And if you have any questions along the way, the EC2 documentation, it's a great resource, and it can cover even more than I could get to today. Otherwise, launch an instance and start testing your app. Thank you.